Hello everyone, welcome back to another video. So today we will discuss editorial for weekly contest 396, and I was able to solve first three problems only. So if you are looking for an editorial just for fourth question, uh, in this video there will be no editorial for that question because I was not able to solve it. I came close. I have an idea for solving it right now, but during contest I was unable to solve it. I have also pretty decent rank, I would say. So let's just start with first problem. So the first problem is valid word, and we are given some conditions. It contains minimum 3 characters. It contains digits from 0 to 9. It includes at least one vowel and at least one consonant. So we have to just return true if all these conditions are satisfied. This is pretty simple implementation based problem. So in first test case, as you can see, there is one vowel and one consonant, and there are no characters other than digit or alphabet, so that's why we return true. In b3, this has length less than 3, so we have to return false. And in this case, there is an additional dollar sign which is not an alphabet and a digit, so we again return true, and also does not have consonant. Both the conditions are failed, so again answer is false. So first I will check if the length of s is less than 3, then I will directly return false. Then I have declared two variables b and c for vowels and consonant count. And then first condition is a greater than a and less than z. So it will compare ASCII values of s of I that are greater than or equal to ASCII value of small lowercase a, similarly lowercase z. If they are between them, then I'm checking this condition of vowel and consonant. Similarly, if ASCII value is between uppercase A and uppercase Z, again I'm checking vowel and consonant condition. And if it is a digit, I will just continue. And if it is anything else other than vowel, character in lowercase, character in uppercase, or digit, it will go in this else and just return false. And finally I am returning this condition where v is greater than 0 and c is greater than 0. So this is just one liner for taking the condition where there is at least one vowel and at least one consonant. So this was first question. Now we will move to second question. So in this question we are given a string and an integer k, that k is a divisor of n, and we have to uh, in one operation we can pick two indices I and j that are divisible by k, and replace substring of length k starting at I with a substring of length k that you can replace both the one of the substring with other substring. So we have to return minimum number of operations required to make word k periodic. So k periodic means just concatenating uh, first k characters x number of times such that k into x is n, and the obtained string is the word itself. For example, in this case, so and k given here is 4. So string must be something like, let's say x is an arbitrary character, x, y, z, u, x, y, z, then again u, x, y, z, and again u, x, y, z. So my string should be of this form, where uh, after 4 steps the same character is repeating. This x is repeating after 4 steps. similarly this y and this z also. So, and in to make this type of operation, what we can do is we can select two substrings of length k and such that their starting index is divisible by k. So this is 0, 1, 2, 3, and this is 4, and similar this is 8. So I can choose this 4 and 8 because they are divisible by 4, and I can make this string substring of length 4 equal to other substring. For example, I can cut this code and make it equal to leet. Now I have a substring equal to I have a string equal to leet 3 times. Now after each 4 step the character is repeating. So this comes out to be this format as we wanted, and the number of operations we did is 1. That's why answer here is 1. Similarly in this case, uh, then leet again, k here is 2, so I have to process these strings like this, each substring of length 2. Now I have to make all those substrings equal. In base simple terms, I have to make all these substrings equal. Now how can I do that? I can either change one of the I can in one operation what we can do is we can erase this string and replace it by one of the strings other than this. So I can replace le with et. Similarly I can replace co with et and this le with et. Now I have et 5 times and number of operations required is 3. Now here if you have seen similar type of question, you must know in this case answer here is there are 5 number of substrings of length 2 because 10 by 2 5, and the number of operations required to make the minimum number of operations required to make substring all the substrings equal will be 5 minus max frequency of all substrings, max of f of substring. F is frequency because in this case if you see et has 2 frequency and 3 of the other substrings does not are not equal to et. So to replace them I I just have to cut them and make them et. So number of operations will be like 5 minus frequency of et, which is 2 and which is 3. Now this will be minimum when this frequency of substring is maximum. So what I have to find? I have to find substrings and store maximum calculate maximum frequency from it and just return total number of substrings minus mx. So how can I do that? So I declared a map and a counter and mx. Counter is just to count how many strings are there, but it will be equal to n by k itself. There is no need of this. Now what I'm doing is first I'm fixing the starting position of each substring, and that will be 0. For example here 0 then 4 then 8. So in simple terms it will be 0 k 2k up to pk where pk is equal to is less than equal to n. So I fixed starting point, then I will iterate from j I to j I plus k, then I will get this substring. Now for each substring I am increasing the frequency and then taking max of that current substring and finally just returning cnt minus mx. So this is again we have to first simplify this question because this is uh, hard to understand. You have to take this examples and then you will understand it, and after understanding you have to simplify this in these terms and find this formula. So this was again a pretty simple question, I would say. No anything uh, advanced was in this question. Now let's move to third question. Now third question again. Uh, this question is also of string again. Now in this question we are given a string s, which is known as a concatenation of anagrams of some string t, and we have to return minimum possible length of string t such that we can get s from concatenating anagrams of some string t. Now for example, in this case a b b a, one string possible can be b a. So s is a b b a, and let's consider t to be b a. Now for in first arrangement I will make t1 as ab and t2 as ba. So these are just arrangements of original t string. Now I can concatenate t1 and t2, which will give me abba, which is my original string. So via this string I got this s by concatenating multiple anagrams. Anagrams is just rearrangement of these characters such that the frequency of each character does not change in this substring, in this string. So in this question answer was 2. Similarly in C D E F answer comes out to be 4, because the string T should be the CDF, the whole string as itself, because there is no other way below 4. Now first observation is that length of T is a divisor of n, where n is length of s. Because if it is not, let's concatenate k number of anagrams of length of t, then it should be equal to n, because we want string uh, what we can say, we want a string s which has length n. Now k will be equal to n by length of t, and k should be integer. Now if n itself is not divisible by length of t, k will not be an integer. So first observation here was that length of t must be a divisor of n. Now to calculate divisors of n, there would be how many divisors? 2 into sqrt of n will be the number of divisors, which comes out to be around 2 into root 10 into 100. So 200 root 10, which you can consider that it as 700, let's say. And for now, for checking each divisor, we can check if there is answer exists or not. Now how can we do that? Let's say for a b b a, if I have to check for k equal to divisor where k is, let's say 2, because 2 is divisor of 4. Now I will iterate for first k elements and create a occurrence map. Occurrence map is just frequency of each character from A to Z. Now I will again iterate from 3 to next k elements and generate a occurrence 2 map. So this will contain all the characters from frequency of all characters in next k elements from A to Z. Now this and this map should be equal, if both of them are anagrams of same string. Similarly, I will generate for next k elements another occurrence to map, and again I will compare these two maps. So this will I will keep doing this uh, until the last block of k elements, and if I all the occurrence maps are equal, then I will just return this k value if I am iterating from start to end. Else I will just continue to find another answer, and my answer will always be less than equal to n, because n itself is one of the answer. So this was it. If let's see the code for better understanding. So first I'm declaring int n as a slot length, calculating the finding the devices and sorting them. Now what I'm doing is I'm iterating over all devices from start to end, so from low to high, and I'm making the first occurrence map of first k characters and storing it in this, and I will also declare an flag. Now here I'm again fixing the start position, and after fixing start position I am creating a second new occurrence map for next k elements, and then I'm checking if both of them are equal. If 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 not, I'm making f equal to 0 and breaking the loop. Now if f equal to 0, I have to return k, and I never find any. I will always find answer in this do dot size because it contains n itself. So I think this was a pretty interesting question. I thought of using binary search, but uh, I, I don't think be it will work, because anagrams can be like this. So if this works for 3, because this and this are anagram, and if I concatenate both of them. But if I take two anagrams, so length as 2, so this AA, this BA, and this BA, so this AA is not an anagram of BA. So I don't think binary search will work here, but overall complexity here comes out to be 700 into like 10 to the power 5, and again, so n by k times of 26 also. uh, this is 700 into what I can say, n by k into 26, so something like this, and it got accepted. And this was the third problem. Now fourth problem is kind of mathematical question. Proving the solution is important. In this case I tried. I think idea here is to just check for all numbers, all a limit of numbers from the biggest number to, I think, 4 plus 1000 or 10,000, and for each case find the number of find whatever required cost is and take minimum of it, something similar to this. But I will solve this, and I think that's it from my side, and thank you for watching.